Meshing is one of the powerful new tools in RAS 2025. It's particularly useful because you can make a mesh in 2025 and bring it into RAS 7. And so this is an introductory workshop that we do in the class that gives people their first kind of exposure to these meshing tools and the different types of meshes that you can make. To access these workshops, you can go to the standard RAS docs. I'll put the link below. And if you kind of scroll down to RAS 2025, it'll take you to the RAS 2025 page. And then if you go down to tutorials, all of our workshops and tutorials are in there. And if we go to this mesh development intro workshop, it'll take you to the workshop, and all the files you need are there because the only file you need is actually the DEM. And so we give you this TIFF file to start with. All right, and so I've opened RAS 2025, and we're going to create a new project, and we'll call it Mesh Demo. And then the first thing we need, of course, is a projection. And so here is the file I downloaded right here, the TIFF I downloaded. I'm going to drop that there, and it is going to scrape the projection off my TIFF, and I'm ready to go. And so this is a debris basin model in Hawaii. And so what I'm going to do is I'm just going to start by adding the terrain. We'll come over here, and then I will just drag this same file over there, and it will kind of show me, and that looks good to me. I'm going to import that, and then right click and zoom to extent will bring me to the location. All right, so then the first thing that the workshop tells you to do is go ahead and create a geometry. Of course, I want to give it a better name, but this is a workshop. We're going to come in, and you have a conceptual mesh and a mesh. You are not going to touch the mesh. The mesh is going to be a visualization, a realization of the things that you specify in the conceptual mesh. This is what you get to touch. This is what RAS generates. And so we're going to start with the conceptual mesh. And the first thing it asks you to do is draw a region that's essentially a rectangle along this rectangular channel. So that's what I'm going to do. I'm going to zoom in here, and I'm going to turn on my pencil to draw my region. And I'm going to draw my region with 4 of these arcs. There's a reason I'm using 4 arcs instead of just one big rectangle, which you will see. Okay, and so I have my region. And so then if I hover over the region, you'll get this quick picker, and the default is triangles. And so if we say, hey, let's make our default 20, you can see you get a preview of the size there. That'll show you kind of how big that cell is. If I was to go to like 200, you can see with the preview that's already kind of too big. So let's go back to 20, and then we'll just generate our mesh, and we have our mesh in our region. Okay, so the next thing the workshop wanted to demonstrate is what we call the Cartesian cell type. And so we'll come over here, and both of these are squares, so it can get a little confusing about which one's Cartesian. This is quads. Cartesian is this one over here, and so we'll click on that, and we'll keep the same cell type, and we'll regenerate the mesh. And so now what you can see is that this looks like a classic RAS grid. It's kind of got a RAS 7.0 vibe because, we've got our boxes. But as we get close to the edge, the Cartesian mesh uses triangles to deal with kind of irregular boundaries. One of the nice things about Cartesian, though, in 2025 is that you can rotate them. They don't have to stay kind of straight, left, right, up, down. And so we'll go in and rotate them. I'm going to come over here to regions. And then in regions, we've got this rotation. I think that 28 is what I used in the past. So let's take a look at that. We'll regenerate the mesh. And you can see that that actually does a pretty good job aligning these Cartesian cells with flow. Now we still have to use some triangles or some irregular cells at the edge here in order to deal with irregular boundaries, but that works pretty well. And then the other thing is that these actually have a secondary cell size, and so we can elongate them in the flow direction. Let's say we like 20. in the lateral direction, but we actually want to do like a 3-to-1 ratio. So we'll bump this up to 60. And that, again, this kind of shows you the size and shape of the cell you're going to deal with, even though it's not actually going to go in that direction, because the primary cell size is along the longer axis of your region. Okay, so that's Cartesian, but then really the thing that we tend to use in channels like this is what we call quads. And so we're going to come in here and we're going to switch to quads. And what quads will do, quadrilaterals, is it uses the Laplace equation to kind of take rectangles and try to align them with a channel. Now that's not going to look super different here because the channel's rectangular, the channel's straight, so you don't kind of get the benefit out of the Laplacian interpolation, but we do want to have longer than wide. So actually let's go in here and make this, let's do the same thing we did. We say 60 and 20, and you can see that shape looks a lot like the Cartesian cell, but you're not going to have to put a skew on it. We're going to automatically go in and align those quads with flow. You don't get the regular boundaries on the edges. You will notice that here, this edge is a little bit longer than this edge, so RAS has introduced a triangle in order to add an additional quad cell in there. If we were to say maybe make this a little bit more carefully and regenerate mesh, we get rid of that triangle. And now one of the nice things here is the quads take up all the space. They expand, they contract in order to not have to make ad hoc decisions at the model boundary. And that works really nicely when you have to expand or contract. And so that's the next part of the workshop, is we are going to add an expansion contraction section. Let me actually just bring this up to the point where we would expand or contract, and we'll regenerate the mesh. All right, so then what I want to do is I want to go through this expansion. And so I'm going to zoom in on the expansion. And so I'd be much more careful with this if I was doing this project for real. But again, make sure you use multiple arcs here, because all quad regions need 4 arcs. And you can see this this region now has 4 arcs, an upstream and downstream, and a left and right. And the upstream and downstream are just along the long direction. The left to right will be the shorter direction. And so we'll come in here and let's just give this the same. We'll just say that this is a 60-20 quad, which you get your preview, you regenerate the mesh, and you can see that because of the expansion, we've done a nice job keeping these quads aligned with flow, but we have to introduce a few triangles in there in order to make sure that the transition works. Now, what if you actually didn't want to introduce those triangles? What this is doing by default is it's saying, I want to keep this size cell as much as possible. So if I have to introduce triangles to expand or contract, I will. But what if you wanted to make sure that you just kept the same number of cells? It doesn't matter to you if their aspect ratio changes, they get a little bit shorter. What you can do is you can say, actually, I have 8 cells here. And I want to keep 8 cells throughout the model. So you can see I've put that in, I've defined it. And so now all of my other arcs are responding to the data in my regions. But now this arc's been specified, which means it's essentially going to override anything else. And then if I come in here and do the same, now it's going to do what it needs to do in order to keep 8 across all the way through that region. And so if we regenerate the mesh, you can see that it doesn't maintain the cell size, but it maintains the same number of cells across throughout the model, throughout the contraction. If we wanted to control that transition, we could come in here and we could say, actually, I want to make that 12, which means that I'm going to add 4 triangles essentially in order to go from 8 to 12 cells. And I'm going to actually darken these for the display, and I'll just show you how I do that. I'll go in here and we have this vector render scaling. This is good if you want to put something on a PowerPoint. We'll go ahead and make that a 2, and that'll kind of make things bigger and darker so that you can see it better on the video. Those are channel tools. And so I'm going to add the floodplain, and you could do this as one region, but it is basically my practice now, in case I ever want to do quads, to always do my regions with 4 arcs if I can. And so if I just kind of come in here and make sure that triangles are connected, I actually don't have to define anything. If I just say regenerate mesh, it will use this spacing and propagate triangles into the floodplain using the channel spacing. I actually didn't add any additional information. But let's say that this is a floodplain. I want bigger cells out here. So I'm going to go in here. I'm going to say that these cells should be 200. And then I regenerate the mesh. I see that's a pretty big cell out there. What's it going to do? Well, it's going to do its best, right? It's going to go in here and say, well, I can't make this cell bigger than this. In this transition, I'm going to have to keep this 60. And then we're going to use what's called the stretching rate in order to determine how fast it goes from kind of this size to this size you've requested. And you'll notice I actually got a warning here that says, you asked for 200, but you didn't get it. There wasn't enough space in your floodplain to stretch that far. You didn't get to 200. We got you as close as we could, which is a helpful feature. The stretching rate is over here in the region. If you go to region 2, and one of the things, once you have one of these diagnostics, it can get in the way. You just close it down. And so then you come here to your stretching rate, and the higher the stretching rate, the quicker it will try to get to the big cells. And so if we were to go and kind of put a really high stretching rate in here, which is outside the recommended range, but I'll just kind of show you what would happen. You can see that each cell, as you move out, gets bigger faster, but we still don't quite reach 200. We get close though. I like the way it was though. Actually, my cells are not too big, so that smoother transition is fine with me. Okay, so let's then try to do a Cartesian floodplain. And so I'll come in here and I'll make my floodplain. Again, I'll use 4 arcs, including the one that's in there, just in case I ever wanted to go. And actually, if we just kind of did that, let's see what would happen. If I say quads, what's going to happen there? Well, it actually does a really nice job just putting quads in there. I actually like that a lot. I might just go with it. But I was going to show you Cartesian. So let's go in and choose Cartesian. And we want these to be 200. And that's going to be big. Another thing here is you'll notice that cell size isn't just cell size. A 200-foot Cartesian cell is twice as large as a 200-foot triangular cell. So if you want those cell sizes to be about the same, that would be 100, but I want to show you something here, so I'm going to leave it there. And I press regenerate mesh, and that doesn't look good. What's going on there? What happened to my Cartesian? Well, Cartesian regions use triangles to transition between whatever's in the channel and whatever's in your floodplain, and there isn't enough space to transition to these 200-foot cells. Now, if I go in and I change this to a 100-foot cell, now you get your Cartesian cells. We use some triangles to transition, but there's room to have some transition and have a cell in there. And so that's something that happens pretty often, is that people will ask for a really big Cartesian cell and then they won't get any, and they wonder if that part of the model's broken. It's not. You just have to have enough room to transition to Cartesian, reach it, and then actually have a few Cartesian cells. Now, a couple of other things I want to show you here. One is, even though we did a nice job aligning this mesh with flow, if we come in here and look at what's going on here, there is a step structure here, and we definitely want to make sure that our mesh is aligned with the top of that our cell faces are aligned with the top of this structure. And so right now, well, they kind of are. We kind of got lucky, but we want to make sure that that happens. So if we come in here and to do that, I'm just going to add another arc. I'm going to come in here and I'm going to press my S to split and double click and come across here and catch the top of that structure. So when I regenerate my mesh, I get my cell faces exactly where I want them to be. And so managing steps and drops and all your hydraulic controls with arcs is one of the things that you want to do next. The other thing is that over here we have this error message that tells us that we didn't reach the target size. But there are a couple of other things that you can look at. If you go to your conceptual mesh and come over to layer, you can say show global size function. And what that'll do is that actually gives you a numerical value of the cell size you're actually getting. So here, this tells you the cell size you've requested, but you're only getting a cell size of 60 next to the 60s, and then it transitions to, you get up to about 170 or something like that. Plus, it gives you a nice, color coding of how the cell size changes relative to what you've asked for. And so that's a good tool that can also help you evaluate your mesh. So that's an overview of the first workshop, which also is kind of a demo of some of the basic meshing tools. In the next video, we'll do a kind of more complicated geometry that uses more direct skills on how to apply these meshing tools in river situations. With the beta version out, we're going to be pushing out more of these videos to kind of show you some of the new features in RAS 2025.